Welcome to Bear Crop Science Fungicide University 2022 Yield Chasers. My name is Daren Bohannan. I'm a crop protection technical development rep here in Illinois, and I will be going through this presentation, this agenda. First of all, we're going to cover a brief overview of what Fungicide University is. Secondly, we're going to cover some of the chemistry that is available within our portfolio and others. Dive into then fungicide construction and brands in the Bayer portfolio, specifically targeting and covering DEKALB Complete. And then we're going to wrap up the agenda by covering the newest disease that we see here in the Midwest, which is tar spot or Phylochora matus, and a brief overview of the disease, the epidemiology, as well as the data from recent years on the control of that disease, primarily from the universities. So just quickly to get everybody on the same page, to remind them, in order to have a problem with a disease, we have to have three components and time in our favor for that pathogen to infect. We have to have the pathogen, a susceptible host, and the right environment. And so this slide basically depicts that not always are all three of those components in equal amounts, but over time, as we see pathogen, environment, and susceptible host in the same field, we end up developing disease, and the incidence and severity will increase as we see more of any of those three components or all three of them. So just quickly, kind of thinking of fungicides as an important agronomic tool, and I'd like to state that we are not increasing the yield of a particular genetic package by applying a fungicide. We are simply protecting that genetic potential that was there when the breeders built that particular germplasm, either in corn or soybeans. And this value of fungicides over the last couple of decades has definitely proven to be effective in protecting those yields and seeing higher yields from the use of the fungicide on popular varieties, hybrids, and cultivars. Keep in mind that one of the driving factors to our use of fungicides have been the fact that we are, as we change our farming practices to higher populations in a denser canopy, it is favoring the environment in which pathogens like to infest crops, because we've got a more dense canopy, less air movement through the canopy. Therefore, we have moisture that remains for a longer period of time. And oftentimes moisture is one of the driving factors in disease outbreaks. Also, many of our pathogens overwinter on the residue from last year's crop. So where we use a continuous crop of, say, corn after corn and a reduced amount of tillage, and also crop residue that doesn't break down as much as it used to, or it's more, the standability of our crop is better. Therefore, our residue tends to be in the environment for a longer period of time, which also plays into the agronomic increase in need in looking at fungicides. Also, to keep in mind, our crop is more expensive these days to put in, from our fertilizer and nitrogen to our seed and our land rent. So there's a lot more at stake. So there's a higher probability of getting a return on the asset of a fungicide application. And not all acres are treated with a fungicide today. So those untreated acres are always providing inoculum back into your growers or to your fields, and might warrant a fungicide treatment. So a real brief overview of the and this is part of a much larger training that is done for Fungicide U, but I'm going to be very brief here. I'm going to cover the three active ingredients that are the three chemistries that are in the sites of action that are popular in today's row crop, corn and soybean fungicide brands. First of all, we have the strobilurins. Secondly, we'll go into the triazoles, and then lastly, we'll go into the most recent addition into our three-way mixes of the SDHIs. So just taking a look at these particular active ingredients, you can see that the strobilurins are typically very broad spectrum. They cover a lot of different fungal diseases in multiple crops. They primarily inhibit spore germination, so they are preventative only with very limited curative activity. Basically, think of the spore as like a seed, and the seed germinates under the soil. the spore germinates on the leaf surface and then infects through the cuticle. And so if we can stop that infection from occurring in the first place, we'll never have a lesion. These strobilurins also trigger physiological reactions in the plant, which often are attributed to inhibition of ethylene production within the plant, which slows the stress of the plant, gives it more time to produce chlorophyll, and we typically see a greener plant. But keep in mind, these strobilurins, especially when used as solo products, are very prone to resistance development within the disease complexes that we have in corn and soybeans. A second class of chemistries that's actually been on the market a little longer even than the strobilurins is this triazole chemistry class. It too has a very broad spectrum of fungal activity. It is primarily curative, but it does have preventative activity. It will not prevent a spore from getting into the plant, but once that single spore infects a single cell or a couple cells at the cellular level, if it is in the plant, it will arrest the development before a lesion is created, and those lesions then create new spores and new fruiting bodies. And so they do prevent not the initial infection, but they do prevent the lesions from developing in an already infected tissue. Most of the yield increases from the triazoles are, and they're not yield increases, again, yield protection is related to disease control, and these are described by most as moderate to low risk of disease developing resistance to the triazoles. And then the third most recent addition into our brands specific to Bayer are the SDHIs. These are highly specific to certain selective pathogens, very chemistry dependent from one SDHI to another. They are primarily preventative as well, with limited to some curative activity on the surface of infections. They, like the strobilurins, have a high propensity for resistance to develop to them, and most of their yield increases come from either disease or overall plant health processes within the plant. Why is it important to use more than one mode of action in a brand or in a tank mix? Well, simply stated, it combines the strengths of multiple modes of action. If there's a weakness of one, a second or third might pick up that weakness and be a strength. Also, when we look at resistance to the fungicide chemistry class, it's always good to have overlapping multiple modes of action on the same particular pathogen in that crop. In fact, looking at our DEKALB Complete, which is our newest brand in our brand ladder, we have trifloxystrobin, which is a strobilurin chemistry. We have prothioconazole, which is our triazole, very, very strong curative product. And then lastly, the newest addition into DEKALB Complete is flupiram, which is our SDHI. All three of these have good residual activity and amount of residual that is loaded into them creates a longer period of time that we're getting effective modes of action on multiple diseases in the spectrum of both corn and soybeans. Just looking at our label, you'll see that we have the group codes of the group 3 triazoles, the group 11 strobilurins, and the group 7 SDHI, and you can see that our solo brands that we sell in some other horticultural and specialty crops, and you can see the diseases in both corn and soybeans that they all overlap on, whether it's a triazole, the strobilurin component, or the SDHI. Kind of looking at the consistency of the performance of a product like DEKALB Complete, all three of our active ingredients have a disease spectrum that's very wide, so they control everything from fusariums to cercosporas. Fusariums would be involved in a lot of the crown rots and stalk rots. Cercosporas would be your leaf blights like gray leaf spot and frog eye leaf spot. And they also have activity on white mold in soybeans, and as you'll see later in my presentation, tar spot, which is the newest disease that we are combating in corn. All three of our chemistries have good preventative activity, not necessarily preventing the spores from getting in the plant, but preventing a lesion. We rely heavily on the triazole component and prothioconazole for that curative activity. Two of those are very systemic within the plant, The strobilurin is primarily locally systemic, just in the cuticle and movement throughout the leaf surface, and translaminar as it moves through the lipids down into the bottom side of the leaf. And then we get plant health effects or greening effects from both the strobilurin and the SDHI. And just looking at our brand ladder there, you can see Stratego, Yield, Delaro, and Delaro Complete and their effectiveness in corn and soybeans. As we go up in active ingredient and we increase our number of modes of action, we get better activity on corn, soybean diseases, as well as standability and plant health. And this is kind of our brand ladder. I won't spend too much time on it, but an introductory into fungicides might be a product like Stratego Yield, which has 2 modes of action. Delaro, which has those same 2 modes of action, but a much higher rate of prothioconazole. So the best in segment as far as the triazole and curative activity. And then finally, Delaro Complete, that has all 3 modes of action and SDHI included in the triazole and the strobilurin compound or brand called Delaro. Touching on tar spot now, I'm going to get into that update. And again, this is a 2021 update. So for 2022, everything that you will see is prior to 2021, data. And I'm going to get into a little bit of the epidemiology. Some of this was shared by a colleague of ours within Bear Crop Science by the name of Andrea Dolezal. She is a plant pathologist at our Waterman Research Facility in Northern Illinois. So just a little brief history on tar spot. Prior to 2015, it had never been discovered within the United States anywhere in the Corn Belt. It was first reported, as you can see, in that northern central corridor of I-39 in Illinois, and then kind of scattered throughout central and northern Indiana. And it was all found in 2015, possibly introduced by a tropical storm and depression that we had come up called Bill. In August of 2016 and 17, we did see it expand into Iowa and Wisconsin, a little bit up in Michigan, but really it was not causing any real issues. It was coming in very late in the season. And then in late June of 2018, we did observe it in a number of other counties at very severe levels that caused some major yield losses in northern Illinois, northern Indiana, southern Wisconsin, and southern Michigan. In fact, if we look at the map today, on the Crop Protection Network, on the Ag Pest Monitor, you'll see the counties that it is infected by and large throughout all of Iowa, Illinois, Indiana, into Ohio, up into Michigan, and into Ontario as well, and Wisconsin, of course. A little bit about the epidemiology of this disease. It's an obligate biotroph. So it can't be cultured. It's difficult to make an inoculum assay so that we can test genetic performance of plant host resistance. Its origin was in Mexico and Central and Latin America. Was first discovered in 2015, as I indicated. And there was a major epidemic of it in parts of the Midwest, upper Midwest in 2018, and again here in 2020. And we saw yield losses up to 60 bushel, some even higher than that if the standability and the quality of the stock went down and we lost ears to the ground. With ear drop, you could have even more significant losses, or if you had a major wind event, that would drop the corn. The environment that it was based on, that we thought was its ideal wheelhouse from Mexico data, showed that it liked a more temperate temperature of 60 to 70 degrees, and certainly that was the case when we saw a big outbreak in 2018 in our August timeframe. However, this year I would argue this point. I don't think it really has an upper limit on how hot it can get, and it can still thrive. I think the key is when we have high relative humidity and high moisture in the canopy, as noted by Dr. Nate Kluczewski here in 2020. Just like any other disease, it can spread due splash and wind dispersal. Something that's a little bit unique to it compared to other diseases that we see in corn and soybeans is that it has a extended latent period. So from the time that the infection occurs or the spore germinates and gets into the plant till the time that we see the stromata, which is the fruiting body on the leaf surface that creates new pustule or new spores, is a little longer than we're accustomed to. With gray leaf spot, we usually see that latent period be somewhere between 7 and maybe 14 days at the most from infection to actual new lesion creating spores. This disease tends to hang out a little bit longer in a plant before it starts to create the stromata, which are the fruiting bodies, more like a 14 to 21 day latent period. There are many different looks to this particular disease. Most associate this little speck that you see on the left-hand side. Looks just like a little tar spot, like you'd splatter tar on a leaf surface. It's hard to rub off, and if it does, it gets on your thumbnail and doesn't want to come off of it either. Sometimes we see these fisheye lesions, which were very widespread in 2018. We really hadn't seen them prior to that in the United States. So it's a little ring or fisheye around that tar speck. And then in some cases, we get these elongated lesions, similar to like a lesion shape that you would see with a gray leaf spot or some of our other common corn diseases. And as you can see here in these pictures, and especially the one on the right, you can see we might have all three of those symptoms on the same leaf. We can see the elongated tar stromata, you can see the fisheye, and then you can see a singular tar speck. There were several different hypotheses or theories of what is causing this. Could be a reaction by genotype or hybrid reaction to the disease, could be a subspecies or species different within that Phyllochromatus, could be the environment driving it, could be a combination of any of these three. What we do know, and what we thought we knew back in 2015 when it was first discovered in the United States, was that the fisheye and the extreme loss that could occur due to this disease was only associated when we would find this secondary disease called monogramphalomatus, and that was what was oftentimes hypothesized with why you got the fisheye. And in Latin America, certainly this disease is prevalent. But in the United States, we have not still been able to find monogramphalomatus in any of our tissue cultures that we've done in any of the previous years since 2015 when the disease was discovered. So the one theory that we can drop off this list is number 4, but the other 3 probably influence why we see different types of spots on the leaf plant. Again, just looking at some other pathogens that might kind of help weaken the plant, things like gray leaf spot, maybe southern rust, fusarium or crown rots. Those things are all diseases that sometimes exaggerate or accelerate the leaf death and dry down, as we saw in 2021 again. Looking at a severity scale, and this is just kind of a computer-generated severity scale showing what 1% severity all the way up to 25% would look like on a leaf surface, whether it was just the tar spot or whether it was the frog eye or the fish eye look. What we've learned right now is when we see leaves within the canopy anywhere from about 2 to 3%, so around this area, we probably need to be spraying a fungicide or may have even missed our opportunity to get full protection from that disease. So it doesn't take a lot to really accelerate this disease when conditions and environment are correct. So we're going to jump into some data here as I wrap up on tar spot. This was data that was summarized across multiple states, as you'll see in a moment, by Dr. Darcy Talenko, who's an associate professor at Purdue University. So I want to give her credit for these slides. These are also available, as you can see on the background logo, through the Crop Protection Network. So if you Google that, you'll find it. These were uniform fungicide trials that were done on tar spot. This is a severity rating slide from 2019 and 2020. And you will see here that it was in 4 different states in 8 different environments. So a couple of states had more than one location. And you can see here the box that I've circled are all the statistically similar control treatments. And you'll see that our Delaro, which is our 2-way mix of strobilurin and triazole, ranked very well. It was one of the lowest severity ratings in those trials across those 2 years in those 8 environments. You will see here also that the yields correlated with those. Anything with an A by itself above would be statistically higher than anything that doesn't have an A beside it. So you can see Numerically, we were the top yielder with 223, but statistically, we ranked with a few of the other top products in those trials. Taking a look at the 2021 data as it stands alone, you'll see that we expanded into 5 environments this year. So not only were trials done in Illinois, Indiana, Michigan, Wisconsin, but we added Ontario. And again, you can see the severity rating at an R5 timing of DEKALB complete. Now we've actually moved up to our 3-way mode of action in comparison to some of our competitors. These are the yields from those same trials, and you can see statistically everything that was treated had an A or a B. So statistically these were all the same, but numerically one of the 2 highest yielding products in those trials across those 5 environments was DEKALB complete, and they all out yielded statistically the untreated. Finally, I want to give credit to all the folks that work with Dr. Tlenko and some of the collaborators and the research extension support that she received from both the USDA, Indiana National Corn Board. You can see them all listed here, as well as many industry folks, including Bayer and some of our competitors. With that, I just kind of end with these guidelines, which are taken right from the Crop Protection Network. We should be considering fungicides. We've got plenty of tools in the toolbox to help combat tar spot, along with other foliar diseases in both corn and soybeans. There is an app out there that you can download for your iPhone or your device. It's called Tar Spotter, and it will help you with forecasting and managing disease or fungicide application for tar spot in particular. We need to manage our irrigation. The more water seems to drive this disease to a greater extent of potential yield losses. Rotating our crops also will have an impact because of the amount of residue that this is a parasite that can overwinter in our soils, in our residues, in our cold temperatures we have here in the Midwest and upper Midwest. Maybe some management of residues, whether it's some sort of tillage or effect on the residue. And then by all means, we need to scout for tar spot on a regular basis and be prepared to make applications of fungicides and possibly more than one per season. With that, just a reminder, why DEKALB complete? Again, we have 3 modes of action. Each of those have their own unique characteristics, but they all overlap on the major diseases that we see in corn and soybeans, including things like gray leaf spot, tar spot, white mold in soybeans, frog eye leaf spot in soybeans, etc. So with that, I would like to thank you and hope that your 2022 season is profitable and that you chase those yields to their maximum. Thank you.